In today's lesson, we are going to know more about the sample machines, but before knowing the different types of the sample machines, we have to know new vocab. The sample machine and also levers, fulcrum, wheel and axle, inclined planes, wedges, screw, and pulley. So these are the new vocab that we are going to introduce in this lesson. We studied last time that we have something or a device that we use in our daily life to make the work or the tasks easier for me without decreasing the needed work. We call them sample machines. Today we are going to introduce that we have different types of the sample machines that do the work using only one movement. How many types? We have 6 types, which are levers, wheel and axle, inclined planes, wedges, screw, and pulley. So we have 6 types of the sample machines that we use them in our daily life to make the work or the tasks easier for me without decreasing the needed work. We are going to describe a sample machine, one of them today, which is called the lever. What is the lever? Lever, as we can see here, like the crowbar, it's a sample machine made up of a bar, a strong bar. It has to be strong to not easily break it, that pivot or rotates about a fixed point. As we can see here, to move this wooden piece, I have to apply a force, which is here in this point, my input force, and to left it, this is the output force, but I have to fix it on a point, we call it the fixed point, and also we call it fulcrum, the point in which the lever pivot or rotate around, it's called fulcrum, the point that is fixed point. We have different types of levers: first class lever, second class lever, and third class levers. The three of them, they perform the same functions. They make the tasks easier for us, but they are different from each other. In the first class lever, the fulcrum is between the input force and the output force. Also, we can see that the input force and the output force have different direction. The input force points up, but the output force points down, and the fulcrum is in between. So the three types, they have the same function, but they have different positions of fulcrum. In the first one, we call it class or first class lever. We call it first class lever because it has the fulcrum in between the input force and the output force. Also because the direction of the two forces are opposite. They have opposite direction. Like the one that we see here, like the finger tap on the beverage can. It's a first class lever. Why we called it a first class lever? Because it has the fulcrum in between the input force and the output force. Also, the input and the output force have different directions. In the second type or the second class lever, as we can see here, the fulcrum is not between the input force and the output force. No, the one in like the middle or in between them, it's the output force. So the second class lever to the one that has, or the type of lever that has the output force here between the input force and the fulcrum and the fixed point. And also we can see that the two forces act in the same direction. Both of them act upward or in the same direction. Second class lever always make the output force greater than the input force. Always the one that we use to increase our forces, like the nutcracker, like the wheelbarrow that we can see here. We use it to lift heavy things and move them, make the work easier for me. So my input force, as we can see the yellow one, it's smaller than the red or the output force. And here's the fulcrum, the fixed point at the wheel. So why we call the wheelbarrow now as a second class lever? Because it has the output force between the input force and the fulcrum. Also, the two forces are in the same direction. The third one and the last one today is the third class lever. As we can see, the one that has the input force between the fulcrum and the output force. It is the one that has the two forces act in the same direction. But both the input and the output force act in the same direction, but always the output force smaller than the input force. It's not increasing my force. It cannot increase my force, but it does something else, like increase speed, like the hockey pad, or like increase distance, like the manual broom. So it does not increase the force, always have the output force less than the input force. As we can see here, this one, like the manual broom or the rack, it's an example of a third class lever. Why? Explain why it's an example of third class lever, because it has the input force between the output force and the fulcrum. Always the input force, yes, more than the output force. These are the three types of the levers.